Okay, so this is lecture 53 and I'll continue what the derivation I was doing in lecture 52. So let me tell you that what we are doing the orbit equation. And for that, let me pointed out some important steps which we derive in last lecture. First of all we derive d dt equal to, so this is the first important result, that d dt is m angular momentum times mu r square. Okay, so first equation is d dt equal to m mu r square d d theta, implies r dot equal to m mu r square dr d theta. Okay, so this is important result. Then equation of motion, just from the Lagrangian, if you find equation of motion, you will find d dt of mu r dot, this is Euler Lagrangian equation, minus the, if I differentiate the other term m square by 2 mu r square, you will get minus m square mu r cube, which will be f r minus del u del r. So this is the equation, if you recall in the last lecture, this. So this we derive. So these two equation will help us to derive the orbit equation. Okay, also we make a change of variable r to u. So u is 1 over r. So du d theta is basically minus 1 over r square dr d theta, just to simplify the mathematics. Okay, so now let us start with this equation, d dt of mu and r dot I will substitute as m mu r square dr d theta. Okay, minus m square mu r cube equal to f r. I will substitute this equation, I will write in terms of u. Okay, so first I will substitute this d dt of d dt I wrote, d dt is m r square d d theta. So let me use different ink, m mu r square d d theta, mu get cancel here and m I can take outside to m square. So it is 1 over r square dr d theta, simplifying. And then if you have let me write in terms of m square mu r cube equal to f r. So after simplifying this, and we will be using this change of variable, u going to 1 over r, that means this. So if I substitute dr d theta in this expression, we will get m square mu r square d d theta of minus del u del theta, okay, and minus m square u square by mu equal to f 1 over u, and this r square also be u square. Okay, because I am writing now everything in terms of u. Okay, great. So you will find m square u square by mu common. So let us write m square u square and take a minus also common for our convenience. This is plus d2u d theta square. Here also I am taking m square mu, this is mu q, this is r q, r q's will be u q, 1 over r q is u q, right. So this you can, so plus u equal to f 1 over u. Fine. Now let us see. I take this side, so you can have a d2u d theta square plus u equal to minus mu by m square u square f 1 over u. So this is the equation involving u and theta or r and theta. So this is the differential equation for orbit. Okay. So we derive the differential equation for orbit, and it is very simple form. This equation later we will see this equation can be used to find the solution that is r or u in terms of time. This is solution, or alternatively if I have u is given, then we can find the force law. Okay. So both ways this equation is important. So just to illustrate this equation, let us consider one problem. Okay. So let us this is very simple problem. So let me write the problem. A particle in a central force located at r equal to 0 describes the spiral trajectory, which is given by r equal to e to the power minus theta. Prove that the force law, the central force is inversely proportional to RQ. So this is the problem. That means this is the second type of application. Your solution is given, R is given, and you have to find. So solution, let me write solution. So your R is given e to the power u theta, and you have to find f of r. Okay. So since our equation of orbit in terms of u, let us go to the u. So r is 1 over u. So u equal to implies equal to 1 over r, which is e to the power theta, and the orbit equation d2u d theta square plus u is equal to minus m square by mu. Just let me see the factor, mu m square u square, mu m square u square. So let me write minus mu m square u square f of 1 over u. Okay. So this is u equal to e to the power theta. So d2u d theta square is same as u. So force law, so this equation say force 1 over u is minus m square u square by mu times d2u d theta square plus u. So this I will substitute m square u square is e to the power 2 theta by mu, m and mu are constant, and d2u d theta is u, so u plus u. So, minus m square by u, u is e to the power theta, so it will be 2 e to the power 3 theta. So, that means minus m square mu 2 1 over r to the power 3. Okay. So, this proves that f r is proportional to 1 over r cube. So, the orbit equation we have derived today, you can easily see it has two different type of use. One is if the solution is given, you can find the force. Alternatively, if the force is given, you can find solution. More examples to illustrate this concept will be considered in the tutorial class. Okay. So, now we will move to the another topic, which is the Kepler's problem. This is very interesting. Kepler's problem is very famous in physics. You know that Earth moves around the Sun is basically a central force problem, because the force F r is proportional to 1 over r square, okay? Because gravitational force is the proportional to the product of two masses, and is indirectly proportional, inversely proportional to the distance between them. Okay. And this is a radial force. Not only that, Kepler's problem exactly similar when a electron moves around the hydrogen atom. So, this is a very famous problem, and you have already studied this problem in your mechanics course. So, now let us find a solution directly for this problem. So, in this problem, so Kepler's problem, as we understand, u equal to minus alpha by r attractive potential, where alpha greater than 0. Okay. Alpha can be when the gravitational constant into the G1 in M1 M2, the gravitational, it can be the Coulomb interaction also, and we have to find the integration of motion. You recall there are two integration of motion. Theta dot was recall angular momentum, mu r square theta dot is the angular momentum. So, theta dot is your m by mu r square. Okay. So, you have d theta integration will be m mu r square d theta dt. Okay. So, theta equal to theta 0 plus m mu r square dt. So, this is coming from the conservation of angular momentum, but there is also constant of motion coming from the conservation of energy. So, energy conservation of energy was half mu r dot square plus half mu r square theta dot square plus u r equal to your E. So, r dot is basically E minus this you can write in terms of so before this line let me write this half mu r dot square, substitute theta in terms of angular momentum. So, mu r square half of course will be there, and m square mu r square and m whole square plus u r equal to the constant energy E. Okay. I hope you are following this mathematics. So, now I can write half mu r dot square equal to E minus u r, and if you simplify this term, 1 mu r square will get cancelled. So, m square m square, I think there is a slight power mistake, m square, just a moment, half mu r square theta dot, that is fine. Now theta dot is m square r square, fine. So it will be minus m square 2 mu r square, and r dot will be 2 by mu e minus m square 2 mu r square minus u square root. So if I calculate r dot as dr dt, then it will be dr dt. So dt will be dr root over 2 by mu e minus m square 2 mu r square minus ur, and this is square root. I am missing 1 over r square factor. So let me theta dot I'll substitute. Okay. So this expression, when we substitute dt in the expression for theta integration, recall that theta integration, this was the theta integration. So recall the theta integration. So it was theta equal to theta 0 theta equal to theta 0 plus m mu r square dt. Now in dt we will write dr square root of 2 by mu e minus dot dot to the power half. So let me write nicely. That was theta equal to theta dot plus integration m mu r square dr root over 2 by mu e minus m square 2 mu r square minus u. Okay. So this is the integration. So let me write, this is in more, theta dot plus m by mu is constant, so we can write dr by r square. Okay, so this dr by r square, and then 2 by mu, and mu, if I take this mu inside, so what will happen? This mu I can take inside, and this, so it will be 2 mu times e minus m square 2 mu r square minus u, and this is all in the square root. So only m is outside, and now we will consider the Kepler's problem. So Kepler's problem is u equal to minus alpha by r. So that will substitute. So theta minus theta 0 in the left hand side. So you will have m, which I can take outside also because it's constant for central force problem, and then we have 2 mu e minus m square 2 mu r square and plus alpha by r coming from the potential, the central force potential. Okay. And in this moment I will substitute in terms of u equal to 1 over r. So del u del r is nothing but 1 over r square del r, no, del u, no, du. So, not del u. So, du will be minus 1 over r square dr. So, you have in the numerator I have already dr by r square. So, I will substitute that here. So, theta minus theta 0 is minus, let us write m outside, du minus I have taken outside, then root over 2 mu, E is constant, no problem, then m square u square by 2 mu, which will get cancelled if I make it inside, plus alpha u. So, this is the integration, and let us make the m also inside. So, m also inside. So, minus will be of course there. So, du, I think this is a straightforward mathematics, you can follow. So, first term under square root will be 2 mu e by m square, because I am tipping the m in the numerator in the denominator. So, it will be 1 over m square, okay. And then you will have u square minus u square, then plus 2 mu alpha, 2 mu alpha, because 2 mu is dividing, multiplying, so 2 mu alpha, and then you have u of course and m square. So, this can be combined as du and du 2 e m square root, everything inside the square root, m square, and then minus u minus mu alpha by m square whole square. So, I have added alpha square mu square by m to the power 4. So, I have to subtract that also. So, minus alpha square mu square m to the power 4, that is fine. These two term already there. So, this term everything under square root, okay. So, this minus du root over 2 mu e by m square minus, there is a minus, do not forget, u minus mu alpha by m square whole square, and minus minus plus alpha square mu square m to the power 4, okay, good. So, then we can write little bit, and this integration is from some initial value of r to some final value of. So, let us write r0, or you can write u0 to u, because this is a integration, and u0 or r0 is related by its 1 over r is u, okay. So, du now 2 mu e m square plus mu square alpha square m to the power 4, this quantity, everything happening inside the bracket, okay, minus u minus mu alpha m square whole square, okay, great. So, then what will happen, minus integration u0 to u du square root of integration. This integration I can think of a square minus okay, some constant root over 2 mu e by m square plus mu square alpha square m to the power 4 whole square minus u square. by substituting, say I substitute u equal to u minus mu alpha m square. So, u prime, so let us write u prime, no problem, and it will change also, no problem. So, du prime is du. This is a simple change of integration. So, this is basically a integration dx root over s square minus x square, which is nothing but minus cos inverse what? Minus cos inverse x by a. In our case, x is basically your u minus mu alpha by m square, and our a in this case is root over 2 mu e by m square plus mu square alpha square by m square. Okay. So, we find the result of our integration. So, result of our integration is theta minus theta 0 equal to cos inverse u minus mu alpha by m square divided by a is 2 mu e by m square mu square alpha square by m to the power 4. Okay. So, this equation we can write that u minus mu alpha by m square by root 2 mu e m square plus mu square alpha square m to the power 4 is cos theta minus theta 0. So, if we write this equation with help of some notation, say I denote P equal to m square mu alpha and a quantity E is root over 1 plus 2 m square E by mu alpha. Suppose I define two quantities, then you can easily see u minus 1 over p. P is m square by mu alpha by m square is 1 over p. So, 1 over p equal to this quantity, and if I take this m square mu alpha common, so or mu alpha m square common from this bracket, I will get m square mu square alpha square alpha mu. So, because it is coming out of square root, so these factors will not be there. Let me mu alpha, and then it will be 1 plus 2 m square E by mu alpha square. You can find the m to the power 4. So, m square will be there, E will be there, 2 mu and mu square will get cancelled to mu, and there will be alpha square. Okay. So, this quantity times cos theta minus theta 0. So, we are almost finding the solution. So, u equal to 1 over p 1 plus e 1 plus e cos m square alpha square is what? So, p 1 plus p and p. Okay. E times cos theta minus theta 0 times this. Okay. So, we will stop here today's class, because we have obtained the solution for Kepler's problem, and in next class, the lecture 54, we will find that we will use this equation to interpret the results which we obtain qualitatively from our analysis of U effective. Okay, so we'll get back to this solution in next class, and then we'll analyze this to our understanding, and we'll find, you will be happy that what exact solution and our qualitative analysis will match. Okay, bye for now. So in next class we'll physical meaning of this formula, and then we'll have a tutorial class on this two body central force problem to end the topics of this week, and in the next week we'll start the theory of small oscillation. Okay, bye for now.